Greetings everyone, welcome to E&E Learning Hub, where I'm going to go through and explain the solutions for different past paper questions as it relates to series parallel combination circuits. All right, so let's begin. So the first question that we're going to be looking at is question 6 from the 2010 past paper. All right, so part A, it says, state Ohm's law in words and formula form. In words, Ohm's law states that the current flowing in a circuit is directly proportional to voltage and inversely proportional to resistance at a constant temperature and pressure. So that's Ohm's law in words. Ohm's law in formula form, current is equal to voltage divided by resistance. All right, so that's it for part A. For part B, it says, name two types of materials which are used as conductors of electricity. The two materials are copper and aluminum. All right, so that's it for part B. For part C, it says, state two applications of resistors in electronic circuits. The first application is that it is used to limit the current flow in the circuit. 2, it is used as a voltage divider in circuits, where the voltage divider gives you a fraction of the input voltage. This is commonly used in amplifier circuits. All right, so that's it for part C. For part D, it says, give two reasons why domestic electric lamp circuits are connected in parallel. The two reasons are, 1, you get a constant voltage. 2, if one lamp is not working, it will not affect the other lamps in the circuit. All right, so that's it for part D. For part E now, it says figure 1 shows a series parallel circuit. So here's figure 1, the series parallel circuit. So it says calculate part 1 of E, the total resistance of the circuit as seen from the source of EMF. All right, so when dealing with combination circuits, I always say to my students, analyze the circuit from right to left. All right, so you're looking at the circuit from right to left and identifying how the first set of resistors are connected. All right, so when looking at this circuit from right to left, we realize that these two resistors here, R4 and R5, are connected in parallel. All right, so the next thing that we want to do is to calculate the equivalent resistor value of these two resistors in parallel, and we're going to call its equivalent resistor value REQ1. Seeing that there are two resistors in parallel, we're going to use the product over sum method. So REQ1 is equal to R4 multiplied by R5 divided by R4 plus R5. That will give us 6 ohm times 6 ohm. That will equal to 36 ohm square divided by 6 ohm plus 6 ohm. That will give us 12 ohm. So that is 36 ohm square divided by 12 ohm, and that will give us 3 ohm. So this is the equivalent resistor value of R4 and R5. Now, the next thing that we want to do is to redraw this circuit and replace R4 and R5 with their equivalent resistor value of 3 ohm. All right, so here is the circuit. So this is the equivalent circuit. All right, so as you can see, we have replaced the two resistors in parallel with their equivalent resistor value of 3 ohm. All right, so again, we're going to use the same procedure on this equivalent circuit. So we're going to start from right to left, analyzing the circuit. So we're going to look at how the first two components are connected in this circuit. So looking from right to left, we realize that the first two components here, R3 and REQ1, they are in series. So we're going to calculate the equivalent resistor value for these two resistors in series. So we're going to call that equivalent resistor value, Req2. So Req2 is equal to R3 plus Req1. That is 3 ohm plus 3 ohm, and that will give us 6 ohm. So that's the equivalent resistor value for R3 and Req1. Again, you're going to redraw this circuit. Again, you're going to redraw this circuit and replace R3 and Req1 with their equivalent resistor value of 6 ohm. All right, so here we have the circuit down here. As you can see, R3 and Req1 have been replaced with Req2, 6 ohm. So again, using this equivalent circuit, looking from right to left, we see that we have two resistors here connected in parallel. So we're going to calculate the equivalent resistor value for these two resistors in parallel, and we're going to call the equivalent resistor value for these two resistors Req3. So Req3, and seeing that it is two resistors in parallel, we're going to use the product over sum method. So Req3 is equal to R2 multiplied by Req2 divided by R2 plus Req2 equal 6 ohm times 6 ohm divided by 6 ohm plus 6 ohm. That will give us 36 ohm square divided by 12 ohm. And that will give us a equivalent resistor value of 3 ohm. All right. So again, we're going to redraw this circuit and we're going to replace R2 and Req2 with their equivalent resistor value of 3 ohm. All right. So here we have replaced R2 and Req2 with their equivalent resistor value of 3 ohm, Req3. All right. So now we can go ahead and calculate the total resistance. So RT is equal to R1 plus Req3. That will give us 2 ohm plus 3 ohm equal to 5 ohm. And that's RT. And that's it for part 1 of E. So let's move on to part 2 now. It says to calculate the total current flowing in the circuit. So IT is equal to VT divided by RT. So VT is given, that is 10 volts divided by RT, which we just calculated, which is 5 ohm. So 10 divided by 5 will give you 2 ampere. So that's it for part 2 of E. Let's move on to part 3. It says to calculate the power dissipated by the resistor R2. All right, so let's look for a resistor R2. All right, so we're going to use this equivalent circuit here. All right, so we need to calculate the power dissipated by this resistor. So we need to know the voltage drop across R2 resistor. To determine that voltage drop, we're going to calculate the voltage drop across Req3. The reason for doing that is because Req3 is the equivalent resistor for R2 and Req2. So once I have the voltage drop for Req3, I now have the voltage drop for R2 and Req2. All right, so let's get to that. So VREQ3 is equal to IT multiplied by REQ3. That will give us 2 amp times 3 ohm, and that will give us 6 volts. So now that we know that REQ3 has a voltage drop of 6 volts, what that means now is that R2 resistor here have a voltage drop of 6 volts. Also, Req2 resistor here have a voltage drop of 6 volts. The reason for that is because these two are in parallel, and Req3 is their equivalent resistor volume. All right, so now we can go ahead and calculate the power dissipated by R2 resistor. PR2 is equal to VR2 squared divided by R2. That will give us 6 volts squared divided by 6 ohm. So 6 volts squared will give us 36 volts divided by 6 ohm. That will give us 6 watt. So it means that R2 resistor here is dissipating 6 watt. All right, so that's it for part 3 of E. Let's move on to part 4 now. It says to calculate the total current flowing in the circuit if R3 is short-circuited. All right, so we're going to use this equivalent circuit. If R3 is short-circuited, basically means that the current will bypass R3 in the circuit. So basically, you can say that R3 doesn't really exist. All right, so we can mark that out. Now, seeing that we're using this equivalent circuit, we'll have to calculate the total current without R3. But before we can calculate the total current, we have to know what the total resistance is. So again, when analyzing the circuit, looking from right to left, we realize that R2 and REQ1 are in parallel. So we'll have to calculate the equivalent resistor value for those two resistors. And we're going to call that equivalent resistor value REQ4. All right, so here we have it. And seeing that the two resistors are in parallel, we're going to use the product over sum method. So REQ4 is equal to R2 multiplied by REQ1 divided by R2 plus REQ1. That will give us 6 ohm multiplied by 3 ohm divided by 6 ohm plus 3 ohm. That will give us 18 ohm squared divided by 9 ohm. And we'll end up with 2 ohm. So now that we have the equivalent resistor value, we can now calculate the total resistance. So the total resistance, RT, is equal to R1 plus REQ4. That will give us 2 ohm plus 2 ohm equal 4 ohm. So that's RT. So now we can go ahead and calculate IT. So IT is equal to VT divided by RT. So VT is 10 volts, that is given, and we just calculated RT, which is 4 ohm. So IT is equal to 2.5 ampere. So this is the total current when R3 is short-circuited. All right, so that's it for this question. All right, so let's move on to the next question. So this is question 1 from the 2013 past paper. So part A, it says state 4 factors that affect the resistance of a conductor. So the 4 factors are the length of the conductor, cross-sectional area of the conductor, temperature of the conductor, and the types of material. All right, so that's it for part A. For part B, it says figure 1 shows the circuit diagram of 6 resistors connected in a series parallel combination. So here's figure 1, and here we have the series parallel combination circuit. All right, so it says calculate the part 1 equivalent resistance of R1 and R2. Seeing that this question is asking us to calculate specific resistance for certain resistors, we don't have to analyze the circuit from right to left. All right, so for part 1, we're to calculate the equivalent resistance of R1 and R2. So here is R1 and here is R2. So we can see that both resistors are in parallel. All right, and we're going to call their equivalent resistor value REQ1. And seeing that it's 2 resistors in parallel, we're going to use the product over sum method. So REQ1 is equal to R1 multiplied by R2 divided by R1 plus R2. That will equal to 8 ohm times 8 ohm divided by 8 ohm plus 8 ohm. That will give us 64 ohm square divided by 16 ohm, and we'll get 4 ohm. So as was mentioned before, we would have to redraw this circuit and replace R1 and R2 with their equivalent resistor value of 4 ohm. So here's the circuit below. So here we have the equivalent resistor value of R1 and R2. All right. So that's it for part one. For part two, it says to calculate the equivalent resistance of R4, R5, and R6. So here's R4, R5, and R6. All right. So to calculate the equivalent resistance of these three resistors, we're going to use the regular format to do so. And we're going to call their equivalent resistor value REQ2. So the formula is REQ2 equal 1 divided by R4 plus 1 divided by R5 plus 1 divided by R6. That will give us 1 all over 1 divided by 12 plus 1 divided by 12 plus 1 divided by 12. That will give us 1 divided by 0.083 plus 0.083 plus 0.083. That will give us 1 divided by 0.25. And that will give us 4 ohm. So again, we need to redraw this circuit and replace these three resistors with their equivalent resistor value of 4 ohm. So here we have the circuit with the three resistor values being replaced with their equivalent resistor value of 4 ohm. All right, so that's it for part two. For part three, it says calculate the total resistance, RT, in the circuit. So RT is equal to REQ1 plus R3 plus REQ2 equal 4 ohm plus 4 ohm plus 4 ohm. That will give us 12 ohm. For part four, it says to calculate the total current in the circuit. So IT is equal to VT divided by RT. So we were given the total voltage, which is 24 volts. And we calculated RT, which is 12 ohm. So 24 divided by 12, that will give us 2 ampere. And that's it for this question. All right, so let's move on to the next question. So this is question 6 from the 2014 past paper, part 1 of A. It says list 3 types of fixed resistor materials used in electronic circuit. So the 3 types of materials are carbon resistors, thin film resistor, and thick film resistor. So these are the 3 types of resistor materials. All right, so let's move on to part 2. It says state the names of 2 circuit components that can vary the electrical resistance in an electrical circuit. So the 2 components are a potentiometer and a rheostat. All right, so that's it for part A. For part B, it says figure 4 shows a schematic diagram of 6 resistors connected in series parallel. So here is figure 4, the series parallel circuit, and it says calculate the part 1 of B, equivalent resistance of resistors R2, R3, R4, and R5. All right, so here is R2, R3, R4, and R5. So when looking at all 4 resistors, we realize that R2 and R3 are in series together. R4 and R5 are also in series with each other. So what we're going to do is to work the resistors R2 and R3 in series, R4 and R5 in series. So the equivalent resistor of R2 and R3 in series, we're going to call that REQ1. So REQ1 is equal to R2 plus R3. That will give us 30 ohm plus 10 ohm equal 40 ohm. All right. So next up, we're going to work R4 and R5 in series. And for their equivalent resistor value, we're going to call it REQ2. So REQ2 is equal to R4 plus R5. That will equal to 15 ohm plus 25 ohm. That will give us 40 ohm. So now that we have these two equivalent resistor values, we're going to redraw the circuit and we're going to replace these two resistors in series with their equivalent resistor value and these two resistors in series with their equivalent resistor value. And here we have the circuit with R2 and 3 being replaced with their equivalent resistor value, REQ1, 40 ohm, and R4 and R5 being replaced with their equivalent resistor value of REQ2, 40 ohm. So now we're going to calculate the equivalent resistance of REQ2 and REQ1. And we're going to call that equivalent resistor value REQ total. So seeing that these two resistors are in parallel, we're going to use the product over sum method. So REQ total is equal to REQ1 multiplied by REQ2 divided by REQ1 plus REQ2. So that will give us 40 ohm multiplied by 40 ohm divided by 40 ohm plus 40 ohm. That will equal to 1,600 ohm square divided by 80 ohm, and that will give us 20 ohm. All right. So the next thing that we're going to do is to redraw the circuit and replace these two resistors with their equivalent resistor value of 20 ohm. All right. So here we have the equivalent circuit where REQ1 and REQ2 have been replaced with their equivalent resistor value of 20 ohm. So that is REQ total right here. All right, so for part 2, it says calculate the total resistance of the circuit. So now that we have this circuit here, we can now calculate RT. So RT equal R1 plus REQ total plus R6. That is 10 ohm plus 20 ohm plus 6 ohm will give us 36 ohm. All right, so let's move on to part 3 now. It says to calculate the total current flowing in the circuit. All right, so IT is equal to VT divided by RT. So we know what the total voltage is that is given. So VT is 18 volts. And we calculated RT previously, which is 36 ohm. So 18 volt divided by 36 ohm will give us 0.5 ampere. All right, so let's move on to part 4 now. So it says to calculate the current IA flowing through resistor R2. All right, so let's scroll back up. So here is resistor R2, and we need to calculate the current flowing through this resistor here. All right. So what we're going to do is to calculate the voltage drop across this resistor here. So once we calculate the voltage drop across this resistor here, we would have the voltage drop across these two resistors, REQ2 and REQ1. And the reason for that is because REQ total here is the equivalent resistor value of REQ2 and REQ1. So whatever the voltage is across REQ total, it is the same voltage across REQ2 and REQ1. All right, so VEQ total is equal to I times REQ total. That will equal to 0.5 amp multiplied by 20 ohm will give us 10 volts. So REQ total here will have 10 volt across it. Also, REQ2 will also have 10 volt along with REQ1, also 10 volt. All right. So now that we know the voltage across these two resistors, we can now calculate the current flowing through R2. To calculate the current flowing through R2, we'll have to calculate the current flowing through REQ1. Why? Because R2 and R3, the equivalent resistor volume is REQ1. So once we know the current flowing through REQ1, we know the current flowing through this portion of the circuit, or we know the value of IA. All right. So IREQ1 is equal to IR2 equal to VREQ1 divided by REQ1, that is 10 volts divided by 40 ohm. That will give us 0.25 ampere. All right. So the current that is flowing through REQ1 here is 0.25 ampere. So because this resistor is the equivalent of these two resistors in series, whatever the current that is flowing through this resistor, it is the same current that is flowing through these two resistors. So it means that the value for IA is 0.25 ampere. All right, so that's it for part 4. For part 5, it says to calculate the voltage drop across resistor R3. All right, so from the previous question, that's from part 4, we would have calculated the current flowing through this portion of the circuit. So we would have calculated IA, which is 0.25 ampere. So looking at the circuit, you realize that R2 and R3 are in series. So it means that it is the same current that is flowing through R2, flowing through R3 as well. All right, so with that, we can now calculate the voltage drop across R3. So VR3 is equal to I, REQ1 multiplied by R3. So that is 0.25 ampere multiplied by 10 ohm, and that will give us 2.5 volt. All right, so it means that this resistor here, R3, 10 ohm, will have a voltage drop of 2.5 volt across it. All right, so that's it for this question. So let's move on to the next question. So this is question 1 from the 2016 past paper. So it says, figure 1 shows a half-watt color-coded carbon resistor. Part A, it says, state the ohmic value indicated by the color code on the resistor shown in figure 1. All right, so brown, the value of brown is 1. The value of black is 0. The value of brown, again, which is the third bond, which is the multiplier, is 10. And the fourth bond is gold, which is plus or minus 5%. So we're going to put the first two digits together, and we're going to get 10. So 10 multiplied by the multiplier, which is 10, will give us 100 ohm plus or minus 5%. So 100 ohm is the ohmic volume. All right, so that's it for part A. For part B, it says determine the designed IS ohmic value of the half-watt carbon resistor in figure 1. All right, so to determine the IS ohmic resistor value, first we'll have to calculate the tolerance volume. So tolerance volume is equal to ohmic value multiplied by the tolerance. So this slash here shouldn't be here, so this slash should be multiplying. All right, so the ohmic value is 100 ohm multiplied by 5%, and that will give us 5 ohm. So the IS ohmic value is equal to ohmic value plus tolerance value, and that will give us 100 ohm plus 5 ohm will equal to 105 ohm. All right, so that's it for part B. All right, for the next part, so this is part 1 of C. It says calculate the equivalent resistance of R2, R3, and R4. So here we have R2, R3, and R4. All right. So looking at these three resistors, realize that R3 and R4 are in series. So we'll have to work that part of the circuit first. So the equivalent resistor value for these two resistors in series, we're going to call that Req1. So Req1 is equal to R3 plus R4. That will give us 4 ohm plus 6 ohm. That will give us 10 ohm. So now that we know the equivalent resistor value of R3 and R4, we're going to redraw the circuit and replace these two resistors with their equivalent resistor value. So here we have the circuit, and we have replaced R3 and R4 with their equivalent resistor value of 10 ohm. All right. So now that we have R2 and Req1 in parallel, we're going to calculate their equivalent resistor value, and we're going to call that resistor value Req2. And seeing that there are two resistors in parallel, we're going to use the product over sum method. So Req2 is equal to R2 multiplied by Req1 divided by R2 plus Req1 equal to 10 ohm times 10 ohm divided by 10 ohm plus 10 ohm. That will give us 100 ohm square divided by 20 ohm, and that will equal to 5 ohm. All right, so there's a little mistake here. So the division part of it, where we divide 10 ohm multiplied by 10 ohm divided by 10 ohm plus 10 ohm is missing. So let me add that there. All right, good. All right, so now that we have that in place, again, we'll have to redraw the circuit, replacing R2 and Req1 with their equivalent resistor value of 5 ohm. So here we have the circuits, R1 in series with Req2. All right, so for part of C, it says calculate the total resistance, RT. So RT is equal to R1 plus Req2 equal to 5 ohm plus 5 ohm. That will give us 10 ohm. So that's RT. For part 3 of C, it says to calculate the total current, IT is equal to VT divided by RT. That is 30 volts divided by 10 ohm will give us 3 ampere. All right, so that's it for these questions related to series parallel circuits.